So today I'm gonna present about the project that we made. It's about the analysis of visual demographic lifestyle for the advertisement recommendation. So the content that I'm gonna talk is had a full session. The first is about introduction, theory, methodology, and experiment result. Let's start about the introduction. So now the advertising is a crucial in the competitive market to stand out and attach the interest. So at that matter, consumer needs get to notice advertising, the importance of the understand preference of the effective marketing and engagement. So the objective of our project is about to develop the system that can recommend the advertisement and the advertisement that show is suitable for the user target, and we want to promote the consumer purchase for the product and the service efficiently. Okay, and our expect benefit is about we can develop the system that can segment service user and assist in the enhancing and refining the advertisement recommendation to be more effective and flexible. So our target user for test system is individual age 15 years and older, and the testing location is in Kim Mongkut University of Technology, Thonburi. So our scope we have 4 points. The first one is consumer segmentation based external characteristic. Second one is advertising recommendation system based on the consumer segmentation categories, such as gender specific and age specific ad. The third one is a system for detect attention on the screen. And the fourth one is the system for predicting gender and age. So the next part is about the theory. So the first one is YOLO. So we use this for a real-time object detection. So we use many part of it. The retina face. So in this model, we use the facial landmark detection. So we can define about the facial landmark, and we can use this for have a headphone estimation. The next one is Mibolo. This is a age and gender prediction model. So in this model, they use the multi-input transformer architecture for better performance. And in our project, we use a tracking model. The first one is a strong sort, and the second one is a bot sort. So we use these two type of the sort for better performance in our system. Next is about the methodology. So we use the programming language is a Python and the TypeScript for the web development, and the tool is the Kaggle for find the data, VS Code for dev, and we use Docker and Kubernetes for deployment. The computer specification is a Intel Xenon CPU 2.00 GHz 2 core and 4 thread. And the GPU we use the Tesla T4 to card. And the website we use Kaggle. And the pre-trained model we use the 4 pre-trained model. As I told you that we have used Nivolo Retina Face and we use YOLO. So we have a different way. The first one is the V8X and the second one is the V8M. About the model development, so in this part we develop about two model. The first one is about the fashion model and the second one is a recommendation model. Let's talk about the fashion model. So we have five five parts that we do in this model. The first one is about the acquisition. So we get the data from many source, but the most one we used it about the data from our test location in the Kim Mongkut University of Technology Thuburi, and we have the file another source like from the Kaggle and from the RoboFlow. So we have the CCTV camera from the shopping mall, and we use the image from the Coco dataset and the dataset from re-identification model. So after we get the data, so we gonna do the person cropping. So we prepare the data with using the YOLO V8X for the image, and after that we can label and the prepare data. The next step is about to do a data labeling. So in this step we use the image from RoboFlow. So we can the RoboFlow have the feature that can label the image. So we categorizing the clothing into two parts. The first part is about the upper clothing that include the t-shirt, long sleeve jacket, top and dress, and the lower clothing have a trouser, short and skirt. After we labeling, so we train the model. So the first step of the data that we get is 9,917 images. So we augment some of the image, so we can get the total about 15,066 images. So we split into the three part of the dataset: the train, the validate, and the test. So we have some of hyperparameter like this. About the epoch is the have the epoch batch size 64, optimizer Adam, and learning rate is 1.001. So the next part is about the advertising recommendation model development. We have the pre three part. The first one is we prepare the data from the two sources. The first source is a portion of the dataset that we use from the RoboFlow detection model, and the second one is the image from our dataset is from Kim Mongkut University of Technology Thuburi. So the overall data that we get for initialize for data training is 5,977 rows. We have some of preparation. The first one is the delete the non-compliant data such as the main wearing dress or main wearing skirt. So if we find this data in our database, so we will pop it out. And the second one is manage the missing value. So we are going to repair the missing value with using mode. Okay. And we have to do a data binding to convert the integer number of the age into the categorizing. We have the three categorized. The first one is the 15 to 19, 20 to 59, and the 60 to 99. And after that we encode the feature of the two types, the nominal and the ordinal. So after encoding the data, so we use the hierarchical clustering for define the group of the uh, a user target for define the advertisement. Okay, next step is about the system overview. That after we train the model, so we implement our model in this system. So we have the three part of the system. The first one is the camera application system, the backend model, and the web application. So the camera application system, we have two main sections. The first one is the fashion detection system, and the second one is the attention system. Let's talk about the face detection system. So we get the input from our test video. It looks like that we have the frame video capturing the student walking movement with the in the university. So in the first step, we use the YOLO detection for detect the people from the incoming image. We have some of the validate the image. The width and the height is have the ratio about 1 to 1.5 in the range of 1 to 5.5. And the minimum bounding box that we use, the width is the 50 pixel and the height is the 80 pixel. So after we get the bounding box of the person bounding box, we use this into the input for the strong sort model. So the model that can track the person between the previous and the next frame. Uh, okay, after we track the person in the image, so we use the YOLO VXM for doing clothing detection. And after we do all of this method, so we're gonna get we're gonna get uh, the upper and the lower part of the person. Okay, the next part in the camera view is a person attention system. So we get the input of another area, but in the same route of the walking. After that, we gonna do a retina face for face detection. So and after that, we use a bot sort for do a person tracking, same as the strong sort. So after we get the bounding box, so we send this image to the detect the facial orientation. So this is the example of the model look like. And we have the set of the condition that we can label that the person in the frame is looking. So we set the yaw either in the range of the minus 30 to the 30 and the pitch is in the range of minus 20 to 20. So this is the example. We can get the status of the looking. Okay. So after we get all of the data from the person, so we send this all information to the Firebase. Okay. The another important part is in the back end. So in this part, we include the age and gender prediction and advertisement analysis. Okay, after we get the image from the camera system, so we send this image into the Mimolo model that we deploy in the backend model. So you're gonna see that the information that get from the camera system is lower part and the upper part data. And after we send the image into the Mimolo model, so we gonna get another information is about the gender and the age. So after we get all of the information that is a gender, age, the upper part and the lower part, so we're gonna save it into the database. Our system have some of data validation. If the system uh, cannot get the information about the upper part or the lower part, or the face, or the model cannot detect the face in the image. So we gonna we gonna delete all of these log information. And if the system predict the age of the person in the image and the value of the age is lower than 15, we are gonna delete these two. Okay, next step is advertisement analysis. So we have three parts. First is the face data from the customer from the database. And second is the advertisement prediction. And third is about to show a video player from the advertisement prediction. So from the camera system, After we get the information of user after 50 seconds before the end of the advertisement from the database. So you're gonna see on the right that we can get the data from the customer collecting. So in the part of advertisement prediction, we get the result obtained for the analysis customer target group, include age range, gender, and clothing preference. So all of these features will be used for analyzing the advertisement group from the like in the image. So we have a calculating module with using the largest target group that determining the proportion of each target group in the total customer base. So after we get the result of the advertisement group, we receive the URL of the target advertisement and we display the result. The last part is the experiment results. So about the fashion evaluation model, so we get that the best round of training epoch is the round 62 with the highest MAP of 78.66, and this is the log information about the loss function, about the loss value. And in about the testing gender and the age detection, we evaluate with these three video. So and this is the following result. And in the testing of the attention model with using retinal phase, we evaluated with the two group. So I'm clarified that the green one is the indicated that the system prediction align with the evaluator, and the red indicated they did not. So we use a 11 evaluator in this test. This is the group 1 of the test result, and this is another test result in the group 2. Okay, that all of this about our project. Thank you.